These are three nodes of openstack: controller, compute, and sender. Then we need to log into dashboard. First, let's check out topology. There are three networks. This one is public network, and the other two networks are private. Let's launch an instance. This instance is on the public network. We also want to attach a volume to this instance. But we need to first create a volume. Let's create a new volume. And go back to instance to attach this volume on this instance. Now let's check out topology again. We can see there are two instances on the public network. Then we need to launch ElasticSearch on these three nodes. We have three nodes, so we need to launch ElasticSearch 3 times. When we launch ElasticSearch, we need to use Elastic user, not root user. And then we go to head plugin of ElasticSearch. Now we can see the status of head plugin is green, and it means all nodes of ElasticSearch work properly. We have three nodes, node 1 to 3, and node 1 is a master node. It doesn't store any data, and node 2 and 3 will store and back up all data. Now we will launch logstarch to filter and collect data from all these nodes sent by rsyslog. Now we can see logstarch is working. Now the logstarch is running, and we need to start our Python script to collect physical CPU usage of these three nodes. This Python script is named with collect. And then we need to start Kibana on controller node. Now we can see index of CPU usage created today on head plugin. Let's go to Kibana. Kibana is ready. First, we need to map index of Elasticsearch on Kibana. This is the mapping process of we can see here the type of these three CPU usage is number. You can see these are original message. And we add this three field of physical CPU usage into the interface. In Virtualize, we can use this data to draw a line chart. Now we create pCPU index we just create. And this is y-axis. We choose average and the cylinder CPU usage and add other matrix. Average, compute CPU usage, and another one. This is for controller CPU usage. Here we choose timestamp. Let's zoom in the picture. And we can see this is the figure of these three CPU usage. Then we stop cylinder node. Let's go back to Kibana to see the data we just create. If the cylinder is stopped, we should have a message have stopping status of cylinder. Here we can see cylinder status is stopping. And the time is just now. And then we restart cylinder node and check Kibana again to see starting status of cylinder. We can use these two status to draw a pie chart in Virtualize pie chart. Click cylinder index. In aggregation, we choose terms, and field is cylinder status. And And we also want to see these messages log level. Here we choose log level. We can see they are all info log. And then we stop RabbitMQ to see whether Kibana can collect disconnection message. Here we can see unreachable. It's the status of RabbitMQ, and then we start RabbitMQ again. Remember to change time range, and we can see here is reconnected. Similarly, we will stop Nova and see whether Kibana can collect the message of Nova. Here we can see lost connection of Nova. Let's start Nova and go back to Kibana. We can see reconnected of Nova. Then we go back to OpenStack dashboard to create a new instance and to check whether Kibana can collect instance information. Let's first create an instance. If Kibana works well, it should collect build time and spawn time of this instance, and also with some other information about this instance, like use disk and use RAM and total of virtual CPUs of this instance. By collecting build time, we can know whether our OpenStack system is busy. If the build time is long, we know our system is really busy, and if the build time is shorter, we know our system is idle. Okay, it will take some time to create this instance. Let's wait for a moment. Let's go back to Kibana to see the build time and spawn time of this instance. We can see here the spawn time and build time is pretty long. In dashboard, we can add figures we have created to virtualize data, and these figures' names have shown their function. We add these figures on the dashboard. We can not only see current data, we can also change the timeline to see historical data. We use machine learning to analyze data. We get files from these three nodes, which contain physical CPU usage, and we use our script to process this data. To get a file contain physical CPU usage and output this data into a CSV file. The CSV file is like this. In Jupyter Notebook, we use three models to do data analysis. These three models are support vector regression, multi-layer perceptron, long short-term memory. By comparing normalized mean squared error, we can know their performance. These figures shows these three models' performance. We can see long short-term memory is better, and the normalized mean squared error also confirm our assumption.